Good morning everyone, thank you for joining me. A continuation here of the power series. PS, I like to symbolize that as that power series, n equals 0 or it could be 1 up to infinity. There's a coefficient component and a variable component. I've shown you all of that in the previous video. I've also stressed the fact power series can have convergence and or divergence based on the values of x. Here's a table which summarizes a set of basic points. Nothing here is absolute because exceptions always apply, but generally and by convention, a series can converge at a single point x equals a. A series can converge at any point in the entire domain of x. And or a series can converge based on this relationship, x minus a absolute value less than r. Diverge if x minus a absolute value is greater than r. What is this r referring to? It's referring to your radius of convergence, a term we will be utilizing a lot in this video. Radius of convergence and interval of convergence. The interval of convergence, the specified interval of x values such that those x values when placed into your series, the power series, you experience convergence. In this particular instance where series converges at a specific value x equals a, your radius of convergence is usually 0. You would have an interval consisting only of a single point. Remember, practice questions will put all of this into better clarity. Series can converge at any x value. Your radius of convergence is infinity. Your interval of convergence is minus infinity to infinity. Perhaps the most important one from all of these three possibilities is this, where you have convergence and divergence based on the interplay of this. The radius of convergence is to be decided. The interval of convergence is again to be decided. But it can have 4 different items or 4 different forms. You see the interplay of the a minus r and a plus r. Well, that's constant. A minus r and a plus r. That's the same in all instances. What differs on each of these instances is the manner of the parentheses: circular, circular, square, square, circular, or square and square. And these would refer to your endpoints of the interval of convergence. Whether those endpoints, how they behave in terms of giving convergence and or divergence, that helps you clarify that inequality of convergence you develop at the very end. You've seen 2 of those style of questions in the previous video, but what we did or what we ignored to do was formalize it by means of these terms: radius of convergence, interval of convergence. Number 2, number 3 are perhaps more common. Number 1 is not so common, but you should be familiar with all. We'll just look at a bunch of examples, show how all of this comes into play, and then we can get some clarity with regards to these terms: radius of convergence and interval of convergence. Because the concept of radius of convergence and interval of convergence is a difficult one, we will look at 2 questions here. Then in the future 1 or 2 videos we will look at more. We're starting out with this: n is equal to 1 up to infinity, x to the power of n and root n. You have to determine the radius and the interval of convergence. Always think about the ratio test, an plus 1 and an, and always think about absolute value. Your an plus 1 terms, we will do this like you're in an exam, so you're not wasting time opening up the series just to see what it is. You just get right into it and you do it in an efficient manner. Here you'll have x to the power of n plus 1, here you'll have n plus 1 in terms of a root. Here you'll have x to the n, here you'll have root n. You're doing the ratio of these two. Limit as n approaches infinity, you'll have the ratio of these two, and I'll open these up. I'll have x to the n times x to the 1 using the laws of exponent multiplied by this flipped around, root n and x to the n. You can cancel this out. You end up seeing this x, and I'll bring that x out. Limit as n approaches infinity, and everything always here is absolute value. You're seeing root n divided by root n plus 1. Let's evaluate that. You're seeing everything right here, n over n plus 1. When you divide everything by the highest order variable exponent, you see 1 over 1 plus 1 over n. Limit as n approaches infinity, that zeroes out. You get root of 1, which is just a 1. All of this just equals to an absolute value of x. Now think about the ratio test in terms of what makes it convergent, what makes it divergent. When the limit values are greater than 1, you have divergence, but when the limit value is less than 1, you have convergence. I'm seeing nothing here in terms of a coefficient of x or a coefficient of this absolute value. This right here would be my radius of convergence because that is your r value. Remember, you're looking at something like a minus r is less than 1. You could have a bunch of different style of parentheses over here. We're looking at a bunch of combinations. It's always a minus r, a plus r. You can have a different characteristic of these parentheses, but I'm focusing in on this. right here. This value right here is your radius of convergence once you have evaluated or taken care of any coefficients that exist with regards to that x. Here the only coefficient of x is 1, therefore that 1 stays 1. If you had a coefficient over here, you take it on the other side and affect that value would then become a new r value. Your radius of convergence would be that. Anyhow, open up this algebraically. X is less than 1, x is greater than minus 1. It's telling you you're somewhere here between 1 and minus 1. You have to fine tune this. And how do you fine tune this? You always look at your endpoints and you place them into your original series. I'm placing those endpoints into my original series and then I see what happens with regard to the outcome. And it's not hard. You've seen something like that before. When you put minus 1 into your series becomes n equals 1 up to infinity. You have minus 1 to the power of n divided by root n. And you're seeing here what will be an alternating series. If you apply the alternating series test, you'll see convergence with minus 1. When you have a 1 placed in that, you're seeing this n equals 1 to infinity. You end up seeing 1 to the power of n, which in all instances is just 1. 1 to the power of anything is always 1, so the n is meaningless, divided by root n. When you expand this out, you can even use the integral test, improper integral from 1 to infinity. 1 over root n dn, it'll always be divergent, and this will be divergent. This tells you that you're looking at a relationship like that. Your interval of convergence will be minus 1, square parentheses, and 1, circular parentheses. X values greater than or equal to minus 1 but less than 1 will be instances where this series will have convergence. For everything else outside of that, you will have divergence, and you see how this question has been answered. The radius and the interval of convergence have been determined. It's not too hard, but it can be slightly tricky. Let's look at this from 0 to infinity. X minus 2 to the power of n divided by n squared plus 1. Find the radius of convergence and the interval of convergence and evaluate it. Ratio test, a n plus 1 term. X minus 2 to the power of n plus 1. And then here you'll have n plus 1 whole square plus 1. Your nth term, or the a-nth term, is exactly what you have at the very beginning. You're looking at the ratio of these two. Open this up and do the limit evaluation. Limit as n approaches infinity. You're doing this divided by this, everything in absolute value. Open that up, you'll have x minus 2 to the power of n times x minus 2 to the power of 1 divided by this. Open this up, you'll have n squared plus 2n plus 2 multiplied by, and I'm bringing the absolute value, this flipped around, n squared plus 1 divided by x minus 2 to the power of n. Cancel things out. This cancels out with that. I am seeing an x minus 2 develop and get pushed outside, and I have limit as n approaches infinity. I have n squared plus 1 divided by n squared plus 2n plus 2. By now when you see this, you know you'll have n squared divided by n squared, you'll have 1. I'm really seeing just x minus 2 in terms of the convergence of a ratio test, rule or condition. It's always less than 1. I'm seeing no coefficient here of x, therefore this right here is my r value. My radius of convergence here is equal to 1. But I have to evaluate this algebraically. X minus 2 is less than 1. X minus 2 is greater than minus 1. X here is less than 3. X here is greater than 1. I'm seeing an informal interval develop to be this. This is an informal because I have to evaluate these endpoints to fine-tune that interval. I'll fine-tune it for you right here by the placement of 1 and 3 into the x right here for the series. It's not too hard. We're looking here at two cases of, at the very beginning I showed you that table. I'm looking at two questions here with regard to the third condition or the third scenario that can play out. We can always look at other scenarios in other videos. That third scenario is always the most important. When you put 1 into your series, you have n is equal to 0 and up to infinity. You have a minus 1 to the power of n divided by n squared plus 1. You can evaluate this out. You don't have to, but if you think about it, you'll have alternating series develop. It will be convergent by means of the alternating series test. It will also be convergent by means of the p series test. Here you have something which looks familiar to 1 over n to the power of p, where p is larger than 1. Here p is equal to 2. So by even the means of the p series test and or comparison test, this will be convergent. What happens when you put 3 into the place of x? 3 minus 2 is 1 to the power of n divided by n squared plus 1. 1 to the power of n is meaningless. It's just 1 over n squared plus 1. What do you think? This is convergent or divergent? Well, it looks convergent to me because based on the p series test, you have 1 over n to the power of p. Here p is equal to 2 is larger than 1. Of course it's convergent. I'm seeing convergence in both of these cases. I'll see something which looks like this. my interval of convergence will be this. Remember at the very beginning I showed you 4 possibilities. You could have circle here, you could have circle here, you can have a combination of circle and square, or you can have square in both ends. Those are your 4 possibilities. Here I'm seeing one of that. If you don't accept that this is convergent by means of the p-series test, you can always do an integral test. You don't need to see any of this. You've seen how all of this worked out. You can do the integral test of that and it would very easily confirm a convergent series. You're really looking at nothing other than 0 to infinity 1 over n squared plus 1 dn. This brings out the arctan antiderivative. When you look at everything here from here, you could say limit as t approaches infinity. You're looking at from t to 0. Based on the arctan of infinity is always equal to pi over 2. Think about the graph of the arctan. It always approaches as x values approach infinity in a horizontal asymptote y equals pi over 2. Arctan of 0 is a 0. You do pi over 2 minus 0, you'd get a pi over 2, a very finite area below the curve, which is convergence. A convergent area is equal to a convergent series, and that is truly convergent. Both of these series, in terms of these 1 and 3 values, are convergent. You have that interval of convergence and it's right. Your radius of convergence is equal to 1. Your interval of convergence is 1 and 3, including both. This is not always 1 in every question. It just coincidentally happened to be 1 in both of these questions, because here the coefficient of this, or the x, are nothing other than 1. If you have something which looks like 3, absolute value x is less than 1. Here you take the 3 on the other side, you have 1 over 3. Now your radius of convergence is, if you have something like 1 over 3 absolute value of x, or even within the coefficient of that x, you take the 1 over 3 on the other side, it would make that 1 into a 3. In that case, your radius of convergence is a 3, not a 1. So you can have values other than just 1. Coincidentally, I had 1 in both of these questions. As the final straw for this question, this series is convergent for all values. X is greater than or equal to 1, less than or equal to 3. It will be always convergent. For any values outside of this notation, you will have divergence. And that's it for this video. Thank you for watching.